All right, guys, so these are the finding slope notes, and we're just going to do a little introduction to finding slope off of a graph. So each of these coordinates has a line. We know it's a line because it has arrows on the end, so it goes on and on forever and ever. And we are going to talk about finding the slope. The slope in general is discussing like the steepness of the line, so whether it is positive and really steep or positive and not so steep, negative and really steep or negative and not so steep. We also have zero slope and undefined slope, which we will get to later. But the gist of slope, or one really important way to remember it, is rise over run. So basically we are looking at the vertical change, so how far up and down I'm going between points, and the horizontal change, how far left and right I'm going. And it's a relationship between those two things. One thing we're going to be using is called a slope triangle. So we're going to talk about how to draw those. And then actually on your Delta Math assignment, you're going to be drawing slope triangles as well. So here's a graph, and the first thing I'm trying to do is figure out how I got from A to B. So I'm looking at this first prompt. It says to get from A to B, you move blank units up and blank units to the right. So I'm going to zoom my brain in on A and B. So here's point A and point B. Okay. And this is where we're going to use what's called a slope triangle. So we're trying to figure out how far up we went, how far over we went. Okay. What you want to do is you want to create a right triangle starting at point A, and you want to say, okay, first we're going up. So how do I get up to point B? Well, I'm going to draw a straight up vertical line. Okay. And I'm going to stop it when it is on the same horizontal line as B. So it's going to be 2 units up. And then I'm also going to draw a horizontal line over from B that is going to run into it. So it makes a right triangle. And then what's nice about this is you can say, okay, here's my slope triangle. Okay, so my total vertical change is 2 units because between point A and the horizontal line is 2 units. And then my total horizontal change is 3 units. So I went 3 units to the right. And then that's kind of how we're going to fill in these blanks. So to get from point A to point B, you went 2 units up and you went 3 units to the right. Okay, 2 units is our vertical change, 3 units is our horizontal change. So my slope is going to be positive 2/3. I also can see as I read left to right, the slope is going up. So that means it's going to have a positive slope. So 2/3 makes sense. Okay, I also want to find the slope between point B and point C. So I'm going to do the same thing. I'm going to make a right triangle. This is called a slope triangle. Between point B and point C, I want a vertical line that goes up from point B. And again, we're going to kind of keep our eyes on point C and say, okay, it looks to me like it's going up 4 units, and then it's going to be the same height as point C. And then I'm going to have this horizontal line. So that's a perfect right triangle. And I can use it to describe the rise and the run between point B and point C. So that's our little slope triangle. Oh, it's so cute. And then how far am I going up? Well, I'm going up 1, 2, 3, 4 units. So my rise would be 4. And then I'm going over 6. Again, it's got that overall positive look about it because as I move left to right, it is going up. So how do I get from point B to point C? You're going to move 4 units up and 6 units to the right. So the slope between point B and point C is 4/6. Okay. Well, what relationship do we see between these two slopes? Okay. One important thing to realize is that they're actually on the same line, and the slope of the line is consistent. So the steepness of the line does not change. You could draw more points on this line, and that would be okay too. And that's actually what we see when we look at these fractions. One of the fractions is 2/3. The other fraction is 4/6. But remember, we can reduce 4/6 using what we learned earlier in this class, and it's actually going to reduce to 2/3. So even though I was looking at 3 different points and I found the slope between 2 different pairs of those, because they are on the same line, the slope is actually the same for those. So for each example below, shade the slope triangle. The triangle should always be drawn so that you move up or down and then to the right. Okay, so we're just going to kind of follow the prompts. To get from L to M, so I'm going to draw a slope triangle between point L and point M. So again, we're going to draw a triangle. vertical line going straight up from the point on the left until it is even with point M, and then I'm going to draw the horizontal part and color it in because we want it to look cute, nice and colorful. So that is our slope triangle between L and M. And then I'm going to move up 1, 2, 3, 4, 5, 6 units. I'm going to move over 2. So I'm moving up 6 units and over 2 units, 2 units to the right. Again, this has an overall positive shape because as I move my eyes left to right, it is going up. That is the kind of slope you want your bank account to have because you'll have more money than you started with. So 6 units up, 2 units to the right. You can go ahead and reduce that if you want. 6 over 2 simplifies to 3 over 1. Now we are going to look at point JK. I'm not joking. Okay, right triangle, slope triangle. I am going to fill it in. We got some nice KU colors going on this example rock chalk. I want to see how far up I'm going, how far right I'm going. So it looks to me like I'm going up 3. I'm going over 1, which makes perfect sense. Because if I am going up 3 and over 1 to the right 1, and I write that as my slope, that is actually going to agree with the slope I got in the first part. So again, what relationship do I see between the slopes? They are the same, and they should be because they are on the same line. And then the last example on the front, this is actually the only example with a negative slope. This is what you want your bank account to not do. So to go from R to S, so again, we are going to draw in our slope triangle between R and S. So I want to do my up-down change first. So vertical change, I'm going to draw a vertical line straight down from R. And then when I'm at the same level as S, I'm going to draw the vertical part of it. And I'm going to color it in so it looks very nice. And then I want to figure out how far up and down I went. So this is 4 up and down. Okay, and 2 to the right. So this one's actually a little bit different when we do the slope. Because instead of going up, I actually went down. So I'm moving 4 units down, 2 units to the right. But if we have an overall negative slope, here's what you're going to do. Okay, because I did not go 4 units up, I went 4 units down. I'm going to actually make that part of the slope negative. So I didn't go up, I went down. So I'm going to make it -4. And then it's still positive 2 units to the right. And what this is going to do is it's going to reduce to a slope that is negative. So -4 over 2 reduces to -2 over 1. Okay? And that really tells me, as the person grading your test, hey, I see that this slope overall is negative. Okay? As I move to the right, it is going down versus all the other examples we have done where it goes up. Okay? So that's a key difference. Now we're going to look at how we get from Q to T. So this is actually going to be kind of a big slope triangle, but we're going to do it. So I start with the vertical change. So here's the vertical change. Okay, and then here is the horizontal line. And we're going to count those. So to get from Q to T vertically, I went 1, 2, 3, 4, 5, 6, 7, 8 units. And I went right 4. Okay, so to answer those questions, to get from Q to T, you move 8 units down and 4 units to the right. But again, remember with the slope, and I didn't really color it in because it'd be sloppy looking, but there we go. With slope, if you're ever going down, you're going to make that one negative. So my rise is actually going to be -8. My run is going to be 4. And then you'll see when we reduce that, I'm going to get -2 over 1. So what relationships do we see between the slopes? Again, well, they are the same. And that is because all of the lines, or all of the points I'm looking at, are on the same line. So that's basically what I want you to do on the back. Determine the slope for each line on this page. When or where necessary, draw the slope triangle. Then write the slope as a fraction. Remember that when you move down, the numerator is negative. So the top part of the fraction is negative, and you are going to simplify the fraction whenever possible. So go ahead, work on these. I'm going to do maybe 2 examples to help you out, and then you will be turning this in complete at the end of the hour.